Good morning. It's October 11th, and this is your daily brief in science. Here's everything you need to know. The Nobel Prize in Chemistry has been awarded to Demis Hassabis, John Jumper, and David Baker for their groundbreaking development of AI systems that predict protein structures. This achievement marks a significant advancement in the field of biology, showcasing the intersection of artificial intelligence and life sciences. As the Nobel Prize season unfolds, anticipation builds for the upcoming literature and peace prizes, which will be announced in the following days. Additionally, the Sveriges Riksbank Prize in Economic Sciences in memory of Alfred Nobel is scheduled for October 14th. In related news, Canc has made history as the first female laureate from South Korea. She is recognized for her impactful storytelling that explores the complexities of human emotions and the interplay between mental and physical suffering. Her notable work, Human Acts, delves into the traumatic experiences of individuals affected by the violent suppression of the 1980 Gwangju protests, reflecting broader societal struggles in South Korea. South Korea currently faces significant social challenges, including economic inequality and a declining birth rate, alongside the lingering effects of its transition from dictatorship to democracy. These issues resonate deeply in its literature and art. Experts are expressing concerns about the dual nature of technologies, particularly AI, which can yield both positive and negative outcomes. There is a growing consensus among thought leaders that the global community must urgently address the risks associated with AI, similar to the responses required for climate change. While AI has a rich history dating back to the 1950s and 60s, there are worries that its recognition may overshadow traditional scientific disciplines and hinder innovative thinking. A 91-year-old professor emeritus at Princeton has emphasized the need for caution, drawing on his experiences in biological engineering and nuclear physics as a warning against the dangers of powerful technologies. In the tech landscape, despite the initial turmoil following Sam Altman's firing from OpenAI, he has regained significant control and is reportedly set to receive equity in the company. This story continues to evolve, with updates expected as developments unfold. In the competitive realm of AI, companies like OpenAI and Google are making strides in advancing technologies such as video generators, although these products are not yet available to the public. World Mental Health Day, observed annually on October 10th, aims to raise awareness about mental health issues and promote well-being, with this year's theme focusing specifically on mental health in the workplace. This initiative comes at a crucial time, as concerns about mental health responses and the demand for psychological services have surged in recent decades, particularly following the COVID-19 pandemic. Teenagers are especially vulnerable to emotional disorders, with anxiety being the most prevalent issue. Alarmingly, suicide ranks as the third leading cause of death among individuals aged 15 to 24, highlighting the urgent need for effective mental health support. In healthcare, emotional intelligence is vital, yet managing emotional labor is essential to prevent burnout among professionals who face increasing pressures in their roles. The shortage of professionals in healthcare settings exacerbates the situation, leading to excessive caseloads and emotionally draining cases for psychologists. To combat this, creating peer support networks can allow healthcare professionals to share experiences and coping strategies, ultimately enhancing their mental health and overall well-being. Recent research published in JAMA Network Open indicates that mindfulness-based stress reduction therapy may be as effective as antidepressants for treating certain anxiety disorders, although the study faced limitations due to sample size and variance in face-to-face interaction. As responsibilities and ambitions increase, incorporating meditation into daily routines is becoming essential to prevent stress and potential mental health crises. In support of mental health initiatives, a promotion runs from October 10th to October 31st, offering a 5-year money-back guarantee for users who engage with a new meditation app at least once a month. Notably, there is a growing trend of men, including young men, seeking mental health support, marking a shift from the previous dominance of women in this area. The A-Frame framework, emphasizing awareness, appreciation, acceptance, and accountability, provides a structured approach to mental well-being. Researchers at the University of Texas at Dallas have made a significant advancement in the field of chemistry with a new method for synthesizing mirror molecules. These molecules, which can exist in left-handed or right-handed forms, are vital for various medicinal applications. The details of this innovative chemical reaction were published in the journal Science, showcasing the ability to produce a single enantiomer rapidly and efficiently, completing the synthesis in about 15 minutes at room temperature. The new technique involves adding prenyl groups to enones using a specially developed catalyst, which effectively mimics natural molecular assembly processes. The research primarily targets polycyclic polyprenylated acylfluoroglucanols, or PPAPs, a class of over 400 natural products recognized for their therapeutic potential against conditions such as cancer, HIV, and depression. As proof of concept, the research team successfully synthesized enantiomers of 8 PPAPs, including nemorosinol, which has shown antibiotic activity in previous studies. Initial tests on the synthesized nemorosinol enantiomer indicated significant effects against lung and breast cancer cell lines, suggesting its potential as an anti-cancer agent. Dr. Filippo Romiti, the lead author of the study, noted the need for further research to determine which enantiomer of nemorosinol possesses specific antimicrobial or anti-cancer properties. The research has garnered substantial support from various funding bodies, including the Cancer Prevention and Research Institute of Texas, the National Science Foundation, and the National Institutes of Health. Romiti has also received a 5-year, $1.95 million grant from the National Institutes of Health to further his work on natural product synthesis. Looking ahead, he plans to apply this new reaction technique to other classes of natural products, potentially expanding the range of therapeutic applications. Overall, these findings could significantly transform drug discovery and manufacturing processes by enabling efficient synthesis and optimization of natural product analogs. In 2022, approximately 20 million new cancer cases were reported globally, resulting in around 10 million cancer-related deaths. Projections indicate that by 2050, these numbers could escalate to 35 million new cases, highlighting the pressing need for advancements in cancer research and treatment strategies. A critical factor in cancer behavior and immune response is the tumor microenvironment, particularly through tumor-associated macrophages. Among these, leukemia-associated macrophages are especially significant, as they not only support tumor growth but are also linked to poor prognosis in acute myeloid leukemia, or AML. AML is recognized as a heterogeneous cancer with limited treatment efficacy and notable resistance to therapies. This makes the role of the tumor microenvironment and macrophages even more crucial in understanding the disease's progression. Research suggests that targeting macrophages could improve the effectiveness of existing AML treatments. Clinical trials are currently investigating drugs such as pexidartinib, magrolimab, and bexmarilimab. Recent studies indicate that therapies designed to reduce anti-inflammatory macrophages while promoting pro-inflammatory ones may offer benefits in AML treatment. The dysregulation of the PY3-KAK-TMTOR signaling pathway in AML presents potential therapeutic targets, particularly concerning macrophage polarization. Macrophages can polarize into two main subtypes, pro-inflammatory, M1, and anti-inflammatory, M2. M2 macrophages are often associated with tumor progression and immune evasion. In the tumor microenvironment, the polarization of macrophages is influenced by various signaling pathways and cytokines, with M2-like tumor-associated macrophages primarily exhibiting immunosuppressive functions. Understanding the complex interactions between these macrophages and tumor cells is vital for developing more effective cancer therapies. The review underscores the importance of targeting leukemia-associated macrophages due to their role in therapy resistance, emphasizing the need for strategies that can effectively modulate macrophage activity. Lung cancer continues to be the leading cause of cancer-related deaths globally, taking approximately 1.8 million lives each year. Current diagnostic methods, including CT scans and biopsies, often struggle with early detection due to their high costs and lengthy procedures. A recent study has explored a new approach by analyzing blood plasma samples from 36 participants, half of whom were healthy and the other half diagnosed with non-small cell lung carcinoma, or NSCLC. This research focuses on integrating Raman and Fourier transform infrared, or FTIR, spectroscopy with advanced data fusion techniques to improve lung cancer detection from blood plasma. The results indicated that Raman spectroscopy outperformed FTIR in terms of model accuracy, achieving an accuracy of 0.85 compared to FTIR's 0.79. Additionally, the application of low-level data fusion techniques significantly enhanced diagnostic accuracy to 0.99 when feature selection was applied. The study highlights the importance of structural protein changes for cancer detection, with low-level data fusion and feature selection being vital in refining diagnostic models. Statistical analysis showed significant differences in protein-related oscillations between lung cancer patients and healthy controls, suggesting that these proteins could serve as potential biomarkers. The findings propose that combining vibrational spectroscopy techniques may lead to non-invasive diagnostic tools for early lung cancer detection. Key vibrational peaks identified in Raman spectroscopy for lung cancer detection were at 1125 per centimeter, 1587 per centimeter, and 1632 to 1668 per centimeter, while FTIR detected significant peaks at 1055 to 1070 per centimeter and 1699 per centimeter, warranting further investigation into their molecular mechanisms and photonic diagnostic technologies. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.